In this lesson, we're going to look at polar coordinates. And up until now, we've located points in a plane by giving rectangular coordinates, so an x coordinate and a y coordinate. And now we're going to have new coordinates. We're going to have the number r and theta, and these are polar coordinates. And so we're going to start off with a polar coordinate system, which is basically you have a polar axis, which is a ray that extends to the right. So if we look down here, we've got a ray that extends to the right, and that point on the end is called the pole. Right, so we've got our ray, which is our polar axis, and we have a pole, which is the end point. And in this system, the absolute value of r is basically the distance a point away is from the pole, and theta is basically the angle that the ray that your point is on makes with the initial side, or with the polar axis. So for example, I have a point I'm just going to plot here. R is the distance away, so the absolute value of r is the distance away from the pole. Theta is the angle that new ray makes with the polar axis. Now, in this type of system, when r is positive, your point lies on the terminal side of theta. In this case, so if this was r positive, the point would be right here. If r were negative, then that point would lie on the opposite side of that ray that we've got there. So the point would be over here somewhere. So we have these definitions. We have the polar axis, which is a ray that extends to the right. We have the pole, that is the end point of the ray. And then the polar coordinate, which is the point r theta, okay, is a point that is the absolute value of r away from the pole. If r is greater than 0, the point lies on the terminal side of theta, this one right here. If r is less than 0, the point lies on the opposite. Okay, up here, if you look, it's going to be on the opposite side of that terminal side. If r equals 0, then the point is literally just at the pole. So let's look at some examples down here. We want to plot these 3 points. So in a polar coordinate system, we need r. And we know that the absolute value of r is the distance away from the pole. And 135 is basically the angle for that terminal side that point lies on, excuse me. So I'm going to mark off 135 degrees first to locate this point. So I know it's going to be in the second quadrant. So if I just draw an angle theta, which is coming around here, right, that's my theta. Right? And there is this, the distance away from the pole is 3. So I count out, we've got these concentric circles to indicate our units. So if from this point, I go out 1, 2, 3, and I plot my point. Now, we don't need to keep the angle there. We can simply erase that. It was there just to help us. So I've plotted the point 3, 135. Because 3 is positive, it falls on the terminal side of that angle, which is at 135 degrees. And I am 3 units away from the pole. All right, let's look at this next one right here. We've got r is equal to -4. Now, because the distance away is the absolute value of r, we know the absolute value of 4 is 4. So we're going to be 4 units away from the pole, except this time, because it's negative, we want to draw a point on the opposite side of the terminal side of 60 degrees. So if I drew my angle, I just located 60 degrees, which is right here. And again, you don't have to actually draw the angle. You can just indicate it or visualize it. For the first few practice problems, I'd like to draw it so you can see it. If r were positive, I would just put the point 4 units out, you can see this, 1, 2, 3, 4, at 60 degrees, so that would be my terminal side, and I would plot my point right here. But because r is negative, what I really want to do is come completely to the opposite side of that ray. So I'm not going to put my point on the terminal side. I'm going to go to the complete opposite side, which is over here, and which would be 240 degrees. I'm going to count out 1, 2, 3, 4. So there's 1, there's 2, there's 3, there's 4, and I'm going to plot my point. And again, drawing the angle is not necessary, just visualizing it is, so we could just get rid of that. So there's your point. In a later section, we're going to talk about how to graph that same point or convert that point into rectangular coordinates. All right, let's do this last one. We know r is equal to 2, and because it's positive, our point should lie on the terminal side of theta. Theta is negative, and so if I want to locate negative 3 pi over 2, I'm going to come around like this, and I'm going to end up on actually the terminal side of where pi over 2 is. There's my theta. I know that I'm going to start at the pole and just go up 2, so 1, 2, and I'm going to plot my point. And again, I don't really need the angle here. I can get rid of that. And there's the point 2, negative 3 pi over 2. So what I'd like you to do is pause the video and try the student practice problem, and then start the video back up to check your answer. All right, let's graph 120 degrees. I'm going to locate 120 degrees, which is right here. And again, this time I'm going to just not bother drawing out the angle, but just saying, okay, I know I'm going to be on the terminal side where 120 degrees is. I'm going to just count out 2 from the pole and plot my point. So that's in polar coordinates, that is the point 120 degrees. So negative 3 and 45 degrees, I'm going to locate 45 degrees, which is right here. If that were positive 3, I would be putting my point right here. But it's negative 3, which means I want to be on the complete opposite of where that point is. Is that, which is basically 180 degrees away, right? So I'm going to come across and put my point right here. So this is the point negative 3 and then 45 degrees. Let's come down and look at the next one, which is 3 negative pi. Right, when we rotate in a negative direction, that brings us right to pi. So I'm going to just go out from the pole. I'm going to go out 3. 1, 2, 3. I'm going to plot my point. All right, the last one is 0, 100 degrees. And in this case, it really doesn't matter what the angle is. If your r is equal to 0, you are literally, it's just a point right at the pole. Now I want to slide up here and just look at negative 345. Now in this lesson that we're working on, we're really just focusing on one polar coordinate for each point, but there's actually an infinite number of polar coordinates for each point, and we're focusing on angles that are between negative 2 pi and 2 pi. But think about this. Let's go back up to B. If we think of, or try and find another angle, if you could think about another angle and another value for r that would give you that same exact point that we have right here. So instead of having negative 3, suppose we had positive 3 as our coordinate. That means we would be 3 out, right? And 3 would be any point, right? Any point on this circle here would have an r value of 3, right? We have 3 units out from the pole. Now you could think of what would be a different angle, right? What would be an angle that would get us there? And so we can see that that angle, the angle that that makes with the initial side here, right? Remember, if it's a positive angle, it falls right on the terminal side. A positive R falls on the terminal side of the angle. And another angle that can name that point right there is 225 degrees. So this point right here could also be indicated by a positive 3 and a positive 225 degrees. Again, for our purposes right now, we're just focusing on just giving one answer for each pair. In the next video, we're going to look at how to convert from rectangular to polar coordinates.